So this is another example on spherical mirror. Okay, we are going to be solving another example. So let me read the question and then we tackle the problem. If you are just watching this video for the first time, you are just tuning into this channel for the first time, please subscribe, love, share, please. Thank you. So let's go back to the question. An object is placed in front of a concave mirror whose radius of curvature is 12 centimeters if the magnification of the image produced is 1.5. How far is the object from the mirror? Okay, now when it comes to concave mirror, you can see I already highlighted that, though we don't need this information for this problem, but you never can tell. Okay, now for concave mirror, okay, the focal length is positive. Okay, the focal length is positive, then the image distance is positive, except on a condition or in a situation where the object distance is less than the focal length, except on that condition. Okay, but if not, the image distance for concave mirror is what? Positive. Let's come back to the question. So an object is placed in front of a concave mirror whose radius of curvature is 12 centimeters. Yes, by now we know that the focal length is equal to half of radius of curvature. So we have F is equal to R over 2. Okay, the focal length is equal to what? Half of what? Radius of curvature. And we are giving radius of curvature to be what? 12. So we have 12 over 2, which means we have our focal length to be what? 6 centimeters. So if the magnification of the image produced is, so we have M is equal to 1.5. How far is the object from the mirror? So we are looking for what? U. Okay, what formula are we going to be using? We are going to be using the mirror formula. And what is the mirror formula? It's simply UV all over U plus what? V. Okay, now we are looking for U. We don't know V. So let's use the formula for magnification to see how we can find V. So we have M is equal to what? V over U. What is M? M is 1.5 is equal to V over U. Okay, so we'll cross multiply and then we'll find our V. V is equal to 1.5 over of U. Okay, so now let's substitute this into this formula. Sorry, I'll still write the formula again instead of coming like this. So we have our focal length to be what? 6 is equal to, what is U? U is U times, what is V? V is what? 1.5 of U all over, what is U? U is U plus, and then we have V what? V is what? 1.5 U. Okay, now let's simplify. This times this is 1.5, right? Then U times U will give us U squared. We have our 6 here all over. This is U plus 1.5. There's 1 here. Okay, this is 1U. U is equal to 1U. So 1U plus 1.5U is what? 2.5U. So we cross multiply. Okay, so we have 2 times what? 2.5U is equal to what? 1.5U squared. Okay, so what do? This times this will give us what? 15U, right? Is equal to 1.5U squared. What do again? We divide both sides by U. We divide both sides by U, right? U will cancel U. And then we are left with what? 15 is equal to what? 1.5U. So how do we find U? We divide both sides again by 1.5, right? If we divide both sides by 1.5, 1.5 will go with this, and then we're left with what? 15 all over what? 1.5. Okay? And 15 all over 1.5 will give us 0.5 10 centimeter. Yes, it will give us 10 centimeters. So, we are through with today's problem solving. I hope you enjoyed today's problem solving. I hope you still remember what I said about concave mirror. I said for concave mirror, the focal length is what? Positive. Okay, the image distance is what? Positive, except on one condition, where the object distance is less than the focal length. I'm still Bukola Joseph, the physics enthusiast. Bye.